Today on 6.5, we are going to talk about the complex plane. And the complex plane is where real and imagined numbers meet. The x-axis of the complex plane is where the real numbers go. So the x-coordinates is your real coordinate, and your y-coordinate is where your imaginary coordinates are. So, for example, if I were to have the value -1 minus 3i, I was given that equation or a little binomial right there, -1 minus 3i. Well, here I can transfer that into my coordinates. My actual coordinate is then it's -1 and -3. -3 being my imaginary, -1 being my real. So I would just, to graph that, I would go over 1, down 3. So this, if I call this one A, this is A. And if I wanted to know the absolute value of A, that would be the equivalent to this distance. So then all I have to do is find the distance. So the absolute value of A, so the absolute value of the combined imaginary and real numbers. So let me put that there. We want to put it into the distance formula. So then -1 squared plus -3 squared, that gives me 1 plus 9, which is the square root of 10. And I can't really simplify that anymore, so my absolute value of A is the square root of 10. Let's try a different one. Let's do another one. Let's say we have, we'll say 5i plus 2. Well, here, my 2 is my x because my real number is my 2. So my coordinates is actually 2, comma 5, because 5, my imaginary, is my y. So to graph this, I go over 2, up 5. 1, 2, 3, 4, 5. I'll call this one B. And this will be B. And if I want to find the absolute value of B, I just got to do the distance formula. So here, I get 2 squared plus 5 squared. Erase that. 5 squared. This gives me 4 plus 25, 29. The square root of 29 is my absolute value of B. And that is all we have to learn today.